заместитель председателя правительства,
Deputy Chairman of the Government of the Russian Federation, Dmitry Chernyshenko. This plenary session is about foresight, how AI will change in 10 years. Dear friends, I'm very happy to see all of you in this room, in this AI, in artificial intelligence journey. This is a great day for the scientific community, this conference. Let us thank Sber and Mr. Grev personally for wonderful organization of the Science Day and the whole AI journey. We are used to thinking that AI is just a system of the new economy, and as our president said, Mr. Putin, at the plenary session yesterday, and a couple of hours ago, we can say so as well, we have unique competencies for the full cycle of forming the fundamental language models, starting from their creation and learning to adaptation to the specific industries. This is something that we're doing already, and I must say that our teams are showing wonderful results in various industries. And I think those of you who have visited the stands realize that this is the true reality. It's very impressive. But it's not just about the development of technology, but about the strategic choice which determines the future of this country and even the countries that are in the AI alliance right now. This choice is not to be done blindly. Other people in this room who know the groove effect. You know about it, right? So, for AI, I think this can be especially true because last year, in order for you just to understand where science currently stands in AI and which areas will be prospective and what risks we must foresee in advance, we held a number of foresight sessions in AI. The first foresight was on the 30th of May last year. We were sort of training at that time. And so there were 10 most prospective areas for fundamental research. We determined them, and I underline the fact that this is fundamental research, which serves as a foundation for applied research. And you well know that only after this, commercialization is possible. So 10 areas, they had 37 sub-areas and 113 research tasks, which our scientists thought as the most promising. So based on these results, the Ministry of Economic Development chose a number of research centers in AI. This was already the third wave, based on a very rigorous contest, and the AI as a competence for this research center actually reflected itself in the position of Russia, the number of publications as a whole in AI in Russia, and also it manifested itself in the performance executed by the research centers. But the groove effect is that everything changed in just a year, and our president, Vladimir Putin, said that we should bring this to the international level, and only in this format we may be sure that we are moving in the right direction. And instead of just existing in the state of being detached from the others, it's something that our enemies may want, but we don't want it. So I would like to thank all of the scientists who participated in this international work, including our own universities and research centers, the Sapphire Foundation, the International AI Alliance, and all those who helped. In 2025, the International Foresight in AI was held in 3 stages. There were expert sessions, deep dive interviews, and then we worked on preparing the final report. This was held actually throughout the year, together with research centers, and the event, which we had more than 20 in Russia and abroad. In Russia, there were 10 foresight sessions with our partners, and thanks to our alliance, the International Alliance in AI, there were 11 sessions that were done in Morocco, in the Emirates, in China, 2 times in Shanghai and Shenzhen, Serbia, Pakistan, Uzbekistan, Belarus, Indonesia, Armenia, and Cuba. So a very large and wide geography. This allowed us to calibrate our priorities, considering the fact that there are various scientific schools, so to speak, and it's very important to form a kind of a consensus on all of the tasks. Also, we held deep dive interviews with the scientists in order to determine how they see the prospects of development of science in the area of AI, and why we can actually trust the results that they achieved. You know, it's the scientists, their words that the whole world is listening to. They are being quoted, and they are being learned from. Every of these scientists have a high Hirsch level, and publications, 5-star kind publications behind them. So many of them are participants of our foresight sessions, and more than half of them, more than 150 of them, are from foreign countries. So this included Europe, Asia, North and South America, Africa, and actually with the whole advanced part of the humankind, we worked on this task. Some of our colleagues, the foreign scientists, came to AI Journey specifically to share their own vision of the results of these sessions. And I must say that the interviews after the sessions allowed us to gather independent assessments of which areas are still prospective, which areas are stagnant, where we require additional approaches, etc., etc. Also, there were suggestions on alignment of these tasks, because we understand that we must fine-tune these on a regular basis, and we'll see whether they remain topical. And the most responsible part, everything that we received were put in one pool, and then we finalized the report on the International Foresight. You can see the QR codes on the screen where you can read the digital version of our report and share this with your friends and colleagues, and also would like to hear from you to learn what you think about that. So the results that we see following the foresight in AI, we must say that our Russian scientists are not fundamentally different from the rest of the world. They moved to the top and right with the development curve. So I must say that in a year we strengthened our understanding of the scientific basis and expanded the potential. We need that for groundbreaking results. So this foresight confirmed that the vector for 2024 was right. There are 102 new research tasks, 62 research tasks were changed or clarified by experts, and 14 tasks were either merged with others or removed. So as a result, as I say, the list grew to 102 tasks, and so these considerable shifts are the result of our systemic work. The scientific breakthrough is 100% impossible to plan, but we can change its probability, the probability of scientific breakthroughs, and we must improve the funnel and see that the competences in research is as full as possible, work in all the possible directions, raising the chance of this breakthrough happening. As of now, I think you well know that there's a contest not for the specific technologies, but those who build the ecosystem based on this technology. Maybe even the operating system for the future. Those who are able to do that, those will determine the rules, will set the rules, the others will become dependent on the decisions of others. So we're looking at that in the kind that this is not about chasing someone. but about forming the circuits of the future, which will be based on the shape of the future, based on the specific scientific basis. It should not be just. It should not belong to just one corporation or one nation. It should be for everyone. The 10 areas that the scientists determined for AI, so they can be imagined as a ladder from the foundation to the integration into our real lives. In the foundation we have architectures, algorithms, mathematics, and then we move on to the level of AI agents, models, and security, how they are explained, and then at the top is the integration, AGI, and human-machine interaction, and also the change in the society, the only non-technical part of the research. This is the principle that is in the foundation of our foresight report. Now that you have it, you can take a look at that. We plan actually to share this with all of our partners, circulate it with the government, the UN, also on behalf of the International AI Alliance. So it's been translated into 3 languages, and there were 2 editors and foreign researchers worked on that. So here we are here to listen to those who created this foresight, and I think without further ado we should talk to our scientists. You can see that here there are only 2 chairs, and in this format we're going to work. We're going to invite our speakers here, and the current foresight is under the brand of AI Horizons. The forecast will be updated, and I would like all of us to use this collective brain, so to speak, not something that's given by the generative network, but our own minds, collective minds, to participate in this work and maybe suggest how our unified platform should be called. Let us use this QR code to make your own suggestions. You'll have time to do that. You may think about that. Maybe some thoughts of our experts and scientists will make it easier for you. Then we will calibrate and ask AI. It will help us, tell us that maybe our AI Horizon is a very good name, or it shall remain, or maybe there will be a new one. I would like to invite our first pair of esteemed scientists who will tell us about the areas that are the basis of this research, the architecture, algorithms of machine learning and optimization. I invite the professor from Serbia, head of applied research in Singidonum University, Nebojša Bačanin-Džakula, and director of Innopolis University, Alexander Gasnikov. Please, floor is yours, guys. Let us support them with a round of applause.
Прошу, друзья, занимать свои места. Поглядывайте на экран, поскольку...
Watch the screen, because you will have a limited time for that, and there will be 2 questions to each of you. Please, Professor Bačanin-Džakula, I'm very happy to see you here again. We were in St. Petersburg with you together, and I know you have a very big program in Moscow that you're going to visit the Bolshoi Theater. I'm not sure which play you're going to look, but I hope you like it. Do you have plans? What else do you want to do in Moscow? Well, we can help organize that.
First of all, esteemed Deputy Prime Minister, for Great Russian Federation, many thanks for your kind words. It was an honor meeting you in St. Petersburg Economic Forum as well as here. I love Moscow. I love Russian people. So I'll go to Bolshoi Theater to watch opera Dead Souls. That's, you know, because I want to go to this historical stage, because it's of national level importance to go there. And honestly, the second thing I want to go there is because my future wife is here with me in this very hall, and she wants to go to this because she admires the Bolshoi Theater. But besides this, we will see all other, beautiful sights of the greatest city in the world, which is Moscow, definitely.
Спасибо, спасибо, очень рад
Спасибо. Okay.
за ваше
I'm very happy that you are so warm about Moscow and Russia. While you were talking, I asked GigaChat quickly who is the most popular composer in Serbia, and it told me Stefan Mokranjac.
Yes.
Is it true?
He's one of the most famous
Хорошо, ладно,
compositors.
Гигачат не ошибся.
Means GigaChat wasn't wrong. So we wish you a nice evening at the theater, but we know that this beauty is based on the structure of the play or ballet, so it's done on a certain basis. You will see that, but in AI, it's based on architecture and algorithms. So for us to be on the same page, tell us, please, what is there, what is the foundation, why it specifies the framework of all other AI areas.
So this is the first research area, and it's basically the foundation of all other research area in terms of mathematics and engineering, which is basically the core of modern AI. So this research area is important because it connects architectures, optimization, and the learning formulations into the unified process of model creations. So it's foundation for everything else, because models are the most essential here. Also, when we talk about models, we should mention architecture. Architecture defines how AI represents information, while optimization helps, adapts models to the data. And mathematics here is very important because mathematics provides guarantee of stability, generalization, and robustness of all those models. Finally, I would like to mention that the progress in this area is accelerated through breakthroughs in the AI for science, which in the years 2024-2025 managed to incorporate scientific knowledge into so-called world models. It's also accelerated by using the generative models, generative modeling, and also by using the multi-agent systems, which is very important for the future, as well as federated learning. So that's why that's foundation for all other pillars and focus areas. There are also many other things to tell about this, like LLMs here are very important, which are used to evaluate and to create new architectures. As we all know, each architecture should be adapted for solving particular challenge. Before LLMs, we had to do it manually by using neural architecture search or auto machine learning or by applying meta-heuristic, which is my field. I love this, but LLMs are much better in this because LLMs are able to combine basic building blocks or foundations to build the model which adapts to specific problem. Because according to the NFL, no free lunch theorem, there is no universal model which is able to solve all kinds of tasks. That's why we should adapt the model for each and every particular task, and that's why LLMs here are very important in this area. And also, when we talk about the model adaptation, we have this algebra for AI. Which combines the structural components into architectures and optimizes to adapt the model for particular data set. And this is one of the long-term and short-term predictions in this very important focus and research area.
Спасибо большое. Благодарю вас.
Thank you. Thanks, Professor. Actually, our scientist mathematician here, Alexander, here, today AI is very complex, so that mathematical tools are not usable. We need new algebra, which Professor just mentioned. At the World International Models, we saw the release, for example, of the adaptive system. What are the main challenges in architecture, algorithms of machine learning you see? Dmitry, thank you very much. I think we may be starting with limited generalization, because when a kid and he's or she's being shown the photos of a tiger or a cat, they can discern them one from another, and the networks will have thousands or dozens of thousands of images to understand that. So to bring this to the level closer to the human level, it's actually one of the challenges, and many esteemed experts are talking about that. For example, LeCun. And another challenge is the certainty. So what LLMs give us, whether we can trust them, how can we check it's certain or not certain about the results? This is especially critical in healthcare, for example. So these are the two challenges which are the most important. Thanks a lot. Dear Professor Bačanin-Džakula, when we met you at SPIF, at St. Petersburg Forum, you repeated some of these things. You said that there were going to be large-scale changes in the architecture and algorithms in implementing diffusion models and multimodal systems, and then a distributed architecture even. In the near future, what will happen? What will happen in the year during which we will work and then get together one more time and discuss the results? What should be your forecast?
My forecast is first, as I already mentioned, the development of algebra of AI, which enable combination of architecture and optimizers for solving different challenges. Then one of the short-term forecasts is to develop the adaptive, and scalable AI system, which is enabled for continuous learning and rapid domain adaptation. This is very important because by using the continuous learning, it's basically the concept of model to learn the new things, to train on new things without forgetting the old things. This is very important. Another important aspect is domain adaptation. So the models will be able to learn from the source domain and to apply the very same knowledge to the target domain without requiring subceptual or any kind of retraining the model. Also, I think it's very important that we are going to integrate the scientific knowledge into optimizers and architectures to create so-called world models. So now the model is not going to be based just on the data. It's going to be based on the scientific knowledge from the physics, chemistry, and other domains, so the model is going to adapt better to the new tasks and unseen domains. And also there are many hybrid approaches between, let's say, symbiotic modeling, symbiotic learning, then physics systems, and data-driven systems. And also, I think that there is going to be a rapid change in the symbiotic multi-agent systems, which will enable automatization, fully automatization of machine learning pipelines. So that's like our vision, yeah.
Если это все за год произойдет, будет...
If this happens in 1 year, this will be fantastic.
It's going to be so cool if we go to the domain approach to the architecture.
Points like algebra for AI and adaptive AI models will happen in the next 1 or 2 years, but these last 3 points are like for longer forecast. For the next 5 to 10 years, I think.
Хорошо, да, понятно.
Okay. Thank you very much. Let's give a hand of applause to our guests for the projections, short-term and long-term alike. Let's look further beyond the horizon. Let's ask Alexander Vladimirovich to give a forecast for the longer terms. What's going to be defining for the architecture of algorithms? Well, to make a forecast, we need to get some kind of a training set. At one point, it became very important to understand that the extractor of markers would be best done not manually, but do a convoluted network that will learn the markers itself. And this idea to automate the marking, this is the idea to delegate something to AI, and this trend is going to be maintained. And some labs are actually working. It's not just one assistant helping the lab; they are actually a set of assistants. And if it used to be, designing data for the model and then use the model, now it's a more of a symbiosis between interacting agents. Each agent doing some kind of a training job. They interact with each other and they develop some kind of a process, so it's more of an evolution thing. So my forecast is in that we will be increasingly taking the knowledge available from the synthetic evolution theory, how the human brain evolved, how we became humans, and we will be integrating that into the AI systems, which will in turn increasingly automate and give us an increasing hierarchy of the processes that we encounter in our work and in our creativity, actually. Thank you very much, Alexander Vladimirovich. I was actually waiting for you as a scientist and user. We'll remember our microservice multi-tenant platform, the only one in the world that is used both by the government and scientists, uniting all our scientific research. That's where we are designing the domain principle. That's why it is called domain science. It's very cool that we're actually talking about this today. Thank you very much. A hand of applause to you. Do rejoin the audience, please. And I'm asking to come on stage the professor from Brazil, the leader from the lab at the University of Campinas, Anderson Rocha, and the director of Systemic Programming Institute, Mr. Avetisyan Arutyun.
У вас такой длинный послужной список.
You've got very long track records, gentlemen. I'm actually having to scroll through 4 pages of achievements. Professor Roshan, you are representing Brazil today at this discussion. Benvindu. Can you hear me? Do you have your earpiece on? Yes. Okay. Very warm welcome. You are part of the 2% of the top scientists in the world. You have a rare skill set, starting from computer vision to all the way to digital forensics, digital law. You worked with AI both as an engineer and a research in security and risks. Let's start with a very simple thing, but very important nonetheless. You actually was brought up by your predecessors here on stage. Why is it that the topic of confidence in AI, the trust in AI, resounds so loudly these days?
It's a pleasure to be here. When we enter a plane, we want it to be safe. We want engines to be safe, the fuselage, everything. We want the people that pilot the plane to be also trained, right? So the same is with artificial intelligence. It's here to stay. And it's changing everything that we do, from decision-making to healthcare, to energy, to solving different problems. So when we have a technology that changes everything, we need it to be safe. We need to go as a requirement to have it safe, sound, transparent. We need it to be explainable. So when we have that, then we're going to have social acceptance. But to have social acceptance, it needs to be reliable. When you have a tool like that to help you detect diseases in a hospital, you want it to explain the decision and actually help the doctor, and not just say, yes, there is a tumor and the likelihood is 99%. Okay, but where? Why? How? So when we have that step further, then people will trust it more and use it more. So we need to move from the real tools that are being developed. That's very good. We are here for that. And we need to go to the next step, the explainability.
Спасибо большое за ваш ответ.
Thank you very much for your response, Arutyun Ishkhanovich. Today, the development of AI is moving from the chase of productivity to ensuring the transparency and matching the values of society. What would be your assessment of this transformation of priorities, and what are the main drivers here? Well, hello everyone. Thank you for the opportunity to speak. Dmitry Nikolaevich, I think this is an indicator of maturity for the technology. The penetration of a lot of spheres. We're very much at the outset of the road, but then the implementations really place security on top. And it's important to say that this is not the conventional understanding of security. The social and humanitarian aspects of security are coming to the fore as well. And giving just a tech answer to this is not enough. And, superimposing protections, again, will not be sufficient. Security must be inside by design, starting from the starting point of development. I will not be responding to your question, in 2 minutes. It's a vast question. The important thing is to set the priorities right for the next couple of years going forward. Yes, secure by design. And for this to happen, we need to agree on the standards, the principles, and what they must be in line with, the common values. For sure. There's one danger lying herein. It's good that we are discussing this internationally, because some countries want to build in their own values. And as IT people, as engineers, we are saying that we need to get technologies that will verify, and the values will be, area specific. In medicine, it will be a bit more different in terms of ethics. In politics, totally different. But technologically, we must give the tools for the policymakers or healthcare professionals or other professionals must realize that, must implement that with area-specific characteristics. We have got actually a presidential decree, 809, to the effect that the values are complied with. We need to look at this together with the AI alliance members. We need to identify the values that do not contradict each other. We should start with that value set. My question now is to Professor Roshan. We certainly want to hear your projection, your forecast. What do you think waits for us in the in this sphere in the next couple of years?
Yourself mentioned a few minutes ago, 1 year is already very difficult to predict, right? I used to say to my students in Brazil, 1 year in AI is like a decade. So here we did an exercise. What's going to happen, likely, from 25 to 28? That's the time that we need to discuss standards. We need to discuss regulation. It might be in a year or two, but we need to do that, because otherwise AI will swallow us. It will be present anyhow. So regarding do we do it or not, I think we should do it. Then what's next? We need to, since now, focus on fighting abuses. There are many people that go online that use technology for abuse, to take advantage of others. So we need to develop the technology and the regulation to fight that. And it needs to happen now as well. Looking further, we need, as it was mentioned before, to design the theory, to improve the theory, to make better models, more models that are safer and transparent. And I think that until the year 2032, we need to have that in place.
Спасибо огромное.
Thank you. Thank you very much. Let's remember this forecast. We're going to discuss that in a year. Artem Ishkanovich, you mentioned healthcare, where the price of an error is obviously very high. What do you think the most important criterion is to apply AI in medicine securely and safely? It's very important to identify the risks and jeopardies in every specific case and use AI depending on that. Sometimes, unfortunately, we will not be able to give it autonomy without the humans. And the regulation, the right regulation, is crucial here. At some point, IT community considers this to be a limitation, but this is not so. And here we are actively working with the medical community, with the healthcare community. We R.M.K. Vaccine was announced. We are doing with the academician the reasoning thing. Ivan Seri is sitting in the audience. That's obviously the crucial thing to do, because sometimes IT people do not understand the limitations imposed by the area-specific professionals. If we only are driven by our own knowledge, that will be a limitation. I think going together is the right path. Okay, thank you very much. Do rejoin the audience now. We should stay on the right side of the volume of regulation here. And the Vietnam professor, Anhui and from Skoltech, and the director from Mega Faculty of ITMO, Mr. Alexander Boukhanovsky. Please join us on stage. Do not spare applause. Let's give some encouragement to the speakers. The next area of the foresight, computation for AI. As you will know, computation includes the development of both new computing architectures and the software tools that ensure effective use of computation. Mr. Huifan, you lead several projects with Huawei, where you are rationalizing AI, starting from compression of models and accelerating models, all the way through architectural adaptation. What do you think lays the foundation for computation in AI?
Thank you very much for the introduction, and I'm really honored to be here. So this is second time for me, so I attend the conference, the session they hosted by the Deputy Prime Minister, so I'm very honored to. So again, regarding the questions, so what is the fundamental for AI development, yes? So you see here, that's the scale of the models is really important. So we see the small model from like 10 years ago, and then very big model delivered almost every year.
Close to the mic, please.
Then more important is that we see here the scale of the model, and then the architecture that can support the model to run, to train, and to do fine tuning. And another important is that the architecture is also very important to, the hardware also very important to specialize, to improve the speed of the model and also to reduce the energy. So that's one of the more important factors. So.
Thank you very much, Alexander Valeryevich. All the experts convene in the opinion that the main bottleneck for the next 10 years is the computing power. Obviously, the stake on scaling GPU will not be vindicated. NVIDIA are following this path. They recently got some luck. The bubble did not burst. But are there any alternatives? Yes, Dmitry Nikolaevich, actually there are alternatives, and it goes without saying that using GPU supercomputers is a very expensive thing, but we should remember that the quickest thing is the light. So we should go back to the optoelectronic and photonic neuromorphic computers. Unfortunately, systems like that, as often as not, are one-actor theaters, so they can only perform one transaction, say transformation of markers. They do not cover the entire length of model performance, but you can use them as hybrid systems. You can use them as boosters, as accelerators. You can merge them with classical architectures, perhaps weaker, cheaper, but that symbiosis will give you a winning solution. And this what is going to cover the things that the GPU systems could do. Thank you. Very interesting. Mr. Stefan, how do you treat the symbiotic systems, quantum photonic systems, with the combined with the common GPU systems?
Yeah, thank you for the question. So again, I need to ask a few comments. So the development of AI system. So we see how the GPU develop like every 2 years, 3 years. So new generation it come and it support us not only to accelerate the computation, but the thing is that it now come to reduce the computational more efficient the energy. So about the quantum computing. So in this, many people believe that the benefit of quantum computing will come in the next 10 years, around 2030 or 2040, and definitely you see that the benefit from quantum computing is not for everyone. So it belong to some big company and some national lab. It really have high resource, and we worry about that. This can maybe lead to some the risk that AI might not be open for the public, so for research scientists, educator, or maybe some small company. So there's another way that we think about some like open AI. Not open AI, so AI open for everyone. So I'm sorry about that. So it means that how to modify some existing model using the available resource computing to adapt to some specific application. So it happened here that the model is released, and then you want to use the model for some specific application. You train, you fine-tune that, and the performance that you obtain is not the same as the model that is public claim in the original paper. This is because the architecture, the hardware you use, is not comparable to the original one. So somehow we think about that. Okay, how can we exploit some existing model on the hardware that we have to achieve comparable performance, so that it not really reduce the significance.
Очень дипломатично профессор Фан выразил сомнение.
Very diplomatically. Thank you, Professor. 2030, 2040, very diplomatic. But maybe we should remember your turn of phrase, you know, instead of open AI for everyone. Was that the thing you said? Yes. Thank you. Alexander Valeryevich, perhaps very briefly, what would be your projection about this startup that launches a data center into the space, you know, energy consumption going down tenfold, etc.? Well, energy consumption will definitely go down because in space cooling is much more efficient in space, but the cost of the enterprise is not in cooling. It's about taking it into orbit the right way, using it the right way, and then disposing of it the right way. No one really knows whether this is the right marketing move or whether it's going to be worth anything. Okay, let's observe. Let's wait and observe. Do rejoin the audience now. And I'm now asking the Deputy Dean of Sai University in India, Ajith Abraham, and the State Scientific Research Institute of Aviation System researcher, Yuri Visilter. Dear Mr. Abraham, great to welcome you. When we spoke the last time at the St. Petersburg Economic Forum, you shared your vision of the architectures and ML machine learning. It would be great to hear your opinion as one of the most cited experts in data science on this track, data for artificial intelligence. Please, sir, what do you think?
Good afternoon. First of all, I would like to thank the Deputy Prime Minister, Dmitry Chernyshenko, for all his leadership and for the guidance during the last several months, for having various foresight sessions, summarizing the whole event. On behalf of all the participants, I again would like to thank you for your leadership and this energy. Back home, I tell my leaders that we can also learn from the administrators in Russia, the way they do things, lead the things, guide the scientific community, thanks to your wonderful leadership. It's a very interesting area. It reminds me 30 years ago when I started AI research. So I remember this very interesting analogy, chicken and egg, which comes first, whether it is data, whether it is AI. So in the case of artificial intelligence, we can build models, but without data and without any practical applications, without making an impact to the community, to me, such models are just good in scientific papers, will not have any practical implications. And we should stress and strive hard to do the best we can to innovate new technologies, new methodologies, to make data accessible and available at all times and all means. Because recently, I would say that during the last 3 years, as I see it, a lot of enterprises, I would say countries which are economically privileged, having an upper hand in taking forward this domain. I feel like the field is being hijacked by few enterprises. And I think there is a big need for scientific cooperation. There is a huge challenge for all of us to balance this, what I call as data asymmetry. And there could be a lot of various challenges facing this. First of all, there could be regulatory issues, privacy issues, then the way data is curated at some places. For example, if you want to access data from Antarctica, definitely, then we need to think about in some other perspective. But the way the field is moving and the way we have the frameworks coming up, we need to look at the whole field in 3 different broad domains. I think there is a need for developing benchmarks, because that is how we usually build AI models. So we need to understand the performance metrics by which a model is evaluated. And for that, we need the best possible data available and associated benchmarks. Data forming and maintenance, how we get this data, whether the data is of good quality and whether it is reliable, and maintaining this, because many a times users come in and go, and then some data may get corrupted, and some data could be used for some other purposes. So we need to ensure that this data is maintained and preserved very well. And finally, confidentiality is another major challenge, especially related to specific problem areas. At the same time, data protection. Many a times, I guess the previous pillar mentioned about government, healthcare, finance. So these data we cannot afford to simply leak out of any cloud or any platform. So we need to ensure that we balance this in the best possible way.
Thank you very much, Mr. Vice Chancellor. Yuri, after the speech of Ajith, I would like to hear your understanding of how requirements for data is changing and what benchmark this sets for data for AI. Thank you. I think there are 2 main things in play here. First is how fast the AI solutions are changing. In spring, there was a research by the Meta group that showed that in the last 6 years, every 7 months, the level of complexity of tasks solved by AI doubles. So, every time, we need new and new benchmarks which are capable of estimating these new tasks, this new level of AI that is always being raised and raised. There are also new classes of tasks, the ones that were mentioned in Foresight, multi-language, character, working in the open world, collecting data for body types, what's required for robotics, and the professional competencies. So I think today the strongest frontier here is the data for professional competence. As an example, I can mention the GDP wall benchmark published by OpenAI. GDP is using AI in the economy, and it includes the examples of solving professional tasks for 44 professions from 9 areas of the economy, which the experts with big experience created. And these are the benchmarks that set the frontier in data and AI. Now I have a question to Ajith Abraham. there's an understanding that the data is being limited, the synthetic data do not give the variability, and it sort of leads to a closed circle, and we risk getting into a digital echo and losing or even getting the lack of efficiency curve. What do you think about that?
Yes, I guess as President Putin mentioned on the first day, there is a need to secure data and develop own curation methods, specifically when you deal with high-level sensitive data for various applications. Of course, it is a big challenge because data nowadays is considered as an asset, and many a times getting this data from nowhere it brings a lot of challenges. And typically in practice, what we do for many applications is we use so-called data augmentation. We try to curate data using various generative AI means. But again, nowadays, because of the availability of several platforms, we don't know what is authentic. Even the differences are very small. For example, if you look at the text generated from LLMs, it is very difficult for us to make out whether it is from LLM or it is generated by humans. So looking at some high-level features, some statistical measures, we can of course categorize them as curated or synthetic. But again, for images, for medias, I think there should be means like watermarking is one way to understand whether it is coming from some generated platforms. At the same time, we need to ensure that these data are not misused by some other stakeholders. So employing standards, for example, GDPR and ISO standards are, I think, is mandatory moving forwards, because nowadays, absolutely there is no control, it's absolutely chaos. Because we are dealing with data in a very big scale. I remember 20 years ago, we could do data analysis, analytics in a lab, but nowadays everything is in the cloud, and we are seeing that thirst is like drinking water from a fire hose reel. And the data comes in streams from various sources, could be videos, could be signals, could be healthcare data, could be text. We also need to handle all this variety of data and also veracity. Sometimes we don't know this data is coming from this authentic source, could be someone is injecting something to cause problems or confuse a model. So there are several layers. We need to ensure that security is in place so that we are able to protect and offer the necessary confidentiality for the various stakeholders.
Thank you. I absolutely agree with you. It's good that you remembered our president and what he said. It's true that the standards are obligatory for us to be able to talk to each other, especially in data usage. Yuri, what are the breakthroughs? What do you think, your forecast? What do you expect in working with data?
Мне кажется, что все-таки наибольшего прорыва мы можем...
I think the main breakthrough can be awaited in working with synthetic data, because it's also the main challenge that we're working with, because in many areas we have the situation of the so-called wall of data, where the majority of data that could have been gathered has already been used for learning. This is one of the challenges for the modern AI. Can we create new data for learning? If we can validate it well, for example, in coding, we have very good progress that we're seeing in the last years, and it can go on and go on. And in cases where we cannot validate it very well for complex tasks, here the question is whether we can generate the synthetics. It's more of a philosophical question, whether a teacher, a person, can teach the pupil, which is the AI, something that he himself cannot do it. Because, the learner must overcome the teacher sometime. We'll learn if it's true when we work with synthetic data. Well, if it's based on bad quality synthetic data, and if they're going to mislead or hallucinate or generate additional new data and then train someone around and making the data worse, it's the matter of validation. This is a task for all of us to prepare for the next year. Thank you very much. Please take your seats. And I now invite the professor from Anhui University, Tian, and chairman of the laboratory and transport of the FISTEC lab of modeling, Dmitry Yudin.
Professor Tian.
Professor Tian, I think your name is known to many people who work with optimization and specific computing methods. You're called as the best, youngest scientist in AI in China, and you became one of the most quoted Chinese researchers, and we're very happy to welcome you here at this stage. In Foresight, you're representing the area of AI for narrow tasks, specific tests, and following the forecasts, the narrow AI will be 95% of the economic viability of this. What is the future of this area? What do you think? What are the approaches that can set up the tempo for the coming years?
Thank you very much. Dear Prime Minister, thank you very much for your introduction and invitation. It's my great honor to be here to discuss with you the future development of artificial intelligence. For me, I think the core function of artificial intelligence is to reduce the human workload and to improve the efficiency of industries. And I think currently the neural networks will still be the mainstream technologies for narrow AI in the near future, including for example, fully connected neural networks, convolutional networks, transformers, and diffusion models with their applications in computer vision, natural language processing, and other industrial scenarios. Also, as pointed out by the President on Wednesday, currently the large language models and content generation models would be the most popular AI applications. And both of these two applications are also based on neural networks. In the future, we may shift from the scaling to architectural diversity. And with this, we can innovate some hybrid and also multifunctional models. But this is still under the framework of neural networks. And the paradigm of narrow AI development will not be changed in the near future.
Спасибо большое. Уважаемый Дмитрий Александрович, вы как эксперт в области...
Dmitry, as an expert, what's your view on the development of narrow AI on the international level, including the embodied AI? What may hinder moving from the lab research to the existing solutions? Dmitry, thanks for this question. Actually, the narrow AI is about practical models and the methods which are very well and organically used for robotics, for self-driving cars. And even in robotics, I must say, not just the delivery robots, the walking robots, that one of them was presented yesterday at Journey. These are medical robots and other types of service robots. And I must say that what must we do for that? First of all, we must support open joint projects, international projects, which can integrate modern engineering methods and develop them. In Russia, they are meetups, even in this community, are used. There are international big projects which integrate the technology of self-driving cars, for example, Apollo from Baidu or AutoWare from their association, and also big projects and their creation and support of them. It seems like it's very, very prospective and we can develop them. In addition to that, what is important? The development of the AI that could be aware, find itself in 3D scenes. And now language models cannot do this nicely, and so the modern methods for narrow AI could help do that and raise this awareness. Professor Tian, question to you. Now the difficulty begins where the system must see and understand, and as well as understand how to act. So moving from just getting the information to acting, what's your thought on this?
Thank you very much for the problem. For me, I think this conclusion is correct, and for the future development of narrow AI. Currently, under the framework of neural networks, based on the supervised learning paradigm, I think AI can learn the mappings between input and output. For example, the images and its labels, the description and the generated content, the biological sequence and the analysis results. For this goal, we should have a large number of datasets to deeply train the neural networks so that it can work. But in many scenarios, especially those in science and engineering, we cannot obtain such a large number of datasets for each scenario. It's not a big data, but a small data. In this case, AI are expected to be able to reason, plan, and act in the complex real-world scenarios by themselves without the supervision of human experience. I think it's possible. It can be achieved by reinforcement learning, intelligent optimization, and other technologies other than supervised learning paradigms.
Thank you very much. Dmitry, what's your thought on the realistic trajectory of the development of AI, a narrow and smarter AI, up to the end of next year? To the end of next year, I must say, it's not a simple task. I think the trajectory is as follows. So the academia, the research organizations will create new fundamental models, small ones for the computer vision or natural language processing. And then going on, companies will use them and we will get feedback from them. And then we'll correct these algorithms. Also, we'll get a better quality, the economy, or maybe positive applicable effects, even in healthcare and robotics. And all this up to the end of next year. Small movements, yes, we'll do. We'll be able to do them. We'll track that. Thank you very much. Please take your seats. And now I invite Professor of the Engineering College, R.M.K, and a specialist in AI, Neelakandan Subramani, and Director of the Center of Bioelectric Interfaces of the Higher School of Economic, Alexey Osachi.
Господин Subramani.
Mr. Subramanian, among your scientific interests that define the technical foundation of interaction between AI and humans is the infrastructure that makes systems more responsive, more personalized, more secure. In human-to-AI interaction, the tech foundation and user experience are directly related. What other challenges in your area do you see to be the key ones?
Thank you for your question. Actually, the human-computer interaction, how the people are interacting with the technologies by using some machines. You know, day by day, even we are developing a huge number of technologies that is the only purpose for interacting with the human being, and it has to be very easy to use. Then otherwise it is no meaning for developing a new technologies. And here the key challenges for the future human-computer interactions, take a brain-computer interface. And actually, brain is not a static one. It changes over a time. And for this brain-computer interaction caters for changing over a period of time, we cannot predict how the neural code is working behind of that. That is the biggest complexity here. And also, the blending of physical and digital world technologies like using virtual reality, augmented reality, and 3D environment. And these are the biggest challenges when you focus on cyber sickness in terms of healthcare and other things. To overcome this, nowadays we are interacting with like emotional classifications and text-based emotional classification, voice-based recognition system, and text-based recognition system. But in the future, how we are going to integrate all these model into a single picture, that's what we can say multimodal AI. So these are the key challenges I'm seeing this. And also in terms of AI ethics, like the developed AI model, how it's how we can justify whether the AI model is correctly developed or not. The prediction of developed AI model is also a huge question mark here in terms of explainable AI.
Спасибо, профессор Subramani. Алексей Евгеньевич,
Thank you, Professor. Neurointerfaces, they can read the signals of the brain, rebuild some functions of the brain that have been lost. When is this going en masse, or is this still committed to a laboratory going forward? Thank you very much for the question. The neurointerfaces, they're perhaps split into invasive and non-invasive. Non-invasive are obviously those that read brain activity from the surface of the scalp, of the skull. And it might seem that the devices that could use that technology have been in operation for a long time. You're looking at my scalp with some particular interest. Well, devices like that could accompany meditation, track human emotions, etc. If you talk about further development of technology, we should not perhaps listen to the brain per se, but we should register the activities of autonomous neurosystems, following eyeballs, whether they are diluted. They are a good indicator of how immersed people are in the situation. That might be an area of development. You don't require very strong AI. You just need some ergonomic devices to register those parameters. Talking about invasive interfaces, well, invasive, so far they have remained committed to the lab, yes, and they probably will for a while, but the spectra of such solutions will be expanding. So far we have had very successful trials of the interfaces for the eyesight, for the eye, stimulation of the periphery vision, retina stimulation. That is a good, promising technology. Reinstatement of speech capability. Some systems are able to rebuild the speech capability. Without those interfaces, speech is pretty much unintelligible. So invasive interfaces, yes, still the domain of the medicine, professional surgeries, but they are going to become cheaper and more accessible. Non-invasive, if it's not just about the electrodes, if you talk about the autonomous things, skin reactions, eyes, heart rate reading, we are going to hit the new level of processing for the data and new level of devices. Well, thank you very much. Wish you every success. Do take notice of what Veronika Igorevna Skvortsova is doing in the Brain Institute of the Academy of Sciences. Yes, we are very much involved. Dear Professor, your colleague spoke of emotions. What do you think is going to be the time when machine starts reading emotions correctly? When are we going to learn to sense the humans?
Actually, the human-machine interaction, the AI model and machine will always read the human brain. Okay. Now you can see that people, how many of you sitting with the stress and anxiety and depression, we can easily identify by seeing your facial expressions. And this is also one of the model we can identify the human emotional states. And these emotional states, as well as that sentimental classifications, also will be the future in integration of a single model. And the critical questions for here in the ethical issue, the model which you have developed, it should be a reliable one for the future world. And also, if the data, if you are feeding into the AI model, if it is not a reliable one, then it will be a chance to bypass the human interactions, because the error rate will be very high. So it is our responsibility of the AI engineer to feed the correct data and to develop an AI model for the human-machine interactions. And also, the model which you are developing, and that should be fit to the social impact and social development and for the betterment of human being. So it's our responsibility to develop an ethical guidelines and ethical framework, and it should be reliable and transparency.
Спасибо большое. Ваши
Thank you very much. What are your plans for the next year? What are you going to be showing us in about a year? Well, I would very much like to transition from registering brain activity to high-density matrices. If you look at this line in front of the stage, that's what 1 centimeter of the human brain looks like. Right now, we are reading this activity by electrodes that are about the size of my palm. Hopefully, we can use electrodes that are going to give us dozens of spots per square millimeter. The interfaces that we have about the systems that are pretty much breaking down this wonderful matrix. They are building into the cortex. These are sort of needles. So the desire would be to use the surface electrodes. Yes, and we are doing a partnership with Tsinghua University, initiated by Sber. Hopefully we can advance in this direction in a year. Thank you, colleagues. Do rejoin the audience. And I'm now inviting on stage Secretary General of the International AI Alliance, the Managing Director of Sberbank, Andrey Vladimirovich Neznamov, and the researcher of Center for International Security at Tsinghua University, Mr. Song Bo. Andrey Vladimirovich, in 2021, the National Ethics Code in AI was developed and opened for accession by signing. Do we run the risk that a critical number of nations might actually join this code? Is that a probability? Well, we're very much hopeful that this is going to happen, but that has not come to pass. UNESCO adopted the recommendation. Yes, we have not yet achieved that. UNESCO in 2021 adopted the recommendation on the AI ethics, but the implementation has been lame so far. Struggling? Why? Because the ethics of AI is inalienably related to the culture of civilization. That is something that we studied at the Science Foresight. Right now, most propositions really translate the ethics of the Western countries. So together with Tsinghua University, we are studying the other types of ethics that we should probably note as we develop the global AI ethics. So far in Russia and the countries friendly to Russia, we have been largely successful in doing this. For instance, the Russian Code of Ethics was acceded to by, there's about 150 signatories. We've got about 35 members, so there's demand for that, and hopefully we can develop some kind of a global ethics code under the auspices of the International Alliance. Mr. Song, your research of the Russian region, Chinese foreign policy, allow us to view not just AI, but AI as a factor that changes the rules for global competition, cooperation. And then there's dilemma. Either AI is enhancing structural asymmetries between the countries, or it is an opportunity for a more balanced international environment. Thank you very much, dear Mr. Chernyshenko. I will try to speak Russian. I'm not the best of the Russian speakers, but still.
I'm not
the best Russian speaker, but I did study Russian. I think we live in a world where Technologies penetrate all spheres of human life, and our report is saying that we need a new social compact that would include AI, a society AI compact. We are facing very serious challenges. Technology has been enhancing the gaps between the nations. Some countries are running ahead, some countries are getting left behind. The AI governance is just about as important. So what we think is that the entire world needs to transition from statements to actions and ensure equal opportunity for all nations.
Решательный вариант. Мы считаем, но самый главный, нам нужно в будущее создать международный механизм.
I think we should create an international governance mechanism for AI. That's my answer. Thank you. Thank you very much, sir. Andrey Vladimirovich, this July, a global index to assess AI governance was published, the AI Governance Evaluation Index, where Russia came 30th of the 440 members. Yet we showed a pretty high index of regulation of AI, although we do not regulate AI. What do you think should happen for us to come higher in this index? Yes, this is a very paradoxical situation. We actually did come 9th of the 40 countries in the quality of governance. That is about both the laws and the lack of barriers, the ethics, technical standardization. We're actually in the top 10, although we completely falling through on all the other directions. We are pretty much next to zero on publications in AI governance. AI governance is generally written on by lawyers. We've got several PhD theses in Russia. Not all of them target Russia. A lot of theses have been published in the world on all kinds of things. And we have the metrics on the number of publications. In Russia, we've got zeros here. So the important thing is to start, for the scientific community, is to start paying attention to these topics. Together with the Tsinghua counterparts, we have been doing a lot on the area, researching the law, studying the law. In some points, the index does not have anything about the opinion on AI in Russia, and the surveys place the overall public opinion on a much more positive level with respect to AI versus other countries. So we've got every chance to go higher in that index, but hopefully the scientific community joins us on this.
Shall we raise this index? I hope people are watching us on the internet, a couple of dozens of thousands or maybe more, hundreds. Thank you very much for that, Mr. Sumbo. We're talking about ethics of AI. There is a AI code, voluntary AI code, and participants are joining. On the international stage, we see that there is an intention, a trend for a responsible AI. What do you think are the principles, general principles that will serve as the foundation of our approaches in ethics? Well, what I think, unfortunately, frankly speaking, I don't have the right answer. I think that I actually liked a lot the speech of the esteemed President of the Russian Federation 2 days ago here he said that it was a very interesting thing that children only want only to press a button instead of thinking and doing something on their own. I think that in China there's also this kind of situation that how we solve it. There are companies that create a new system, and in order to make children not just press buttons, but do something else. This is not the right path. I think we must create a new principle that would correspond to everything that the President of Russia said. I think that in the future we need to be protected the humans from losing their cognitive capabilities, and we need to make people, and especially children, think themselves. I found a quote. I found even a quote of of President Xi Jinping when our president visited Beijing. He said that according to the initiative, all countries, regardless of their wealth, must have an equal participation and equal opportunities in the global governance. We must raise the democratization of the international relations and expand the voice of developing countries, and that's what we are going to do. Follow our leaders. Thank you very much. Take your seats.
I invite to the stage Director of Tsingtao University of Science and Technology, Tian Wang, and Director of Skolkovo Institute of Science and Technology, Evgeny Burnaev. Professor Wang, your work on stochastic configuration networks and computational intellect are dedicated to how intelligence can identify complex patterns in data and adapt to changing conditions. What are the breakthroughs that you see in industrial AI, and can we say that lightweight training models can be the best groundwork for decision-making on AI basis?
Okay. First of all, I thank you very much for the good introduction. My job, okay, stochastic configuration network. I created these concepts in 2017. Okay, and then I deeply believe so this lightweight learning model will play the key role in the future, especially for industrial AI, okay? Because we have real-time requirements, we have limited power, we have limited computing resource. So in such a scenario, we can't rely on the well-known training algorithm, for example, very well-known by propagation, but resulting a very complex neural nets. Whatever is a deep structure, single layer. But when we think about this, how to use this learning model in edge computing-based application, so that's became a big issue. Okay, that's my understanding.
Спасибо большое. Евгений Владимирович, на вашей сессии совместной с президентом.
Thank you very much. Evgeny Burnaev, at your session with the participation of the president, he said that smart assistants, intelligent assistants need to be integrated in more and more managerial processes. Which kinds of technology do you think are the best suited now for scaling, and what are the barriers that you see for them to become the norm? What Mr. Wang was talking about is an absolutely crucial part of this process. Speaking of industrial systems, when a model is sitting on the equipment, that model being lightweight is absolutely vital. Such a model can only handle a specific function, though. If we talk about the management of the entire process, we will need a combination of models. Some of the models will be lightweight, some of the models will be in the cloud or on premise, on local servers. So we're talking about a multi-agent system managing the whole process. Of course, there is a certain trend. These systems are being developed. We are recognizing their value. They are becoming more and more adaptive thanks to visual language models, large language models. The main problem with deployment is this. First, there is no established regulation for their installation on existing systems, especially when it comes to critical functions. Then, with the growth of investment, we are getting more and more frameworks of multi-agent systems, but the problem is that they are, to a certain extent, fragmented. We do not have some established best practice based on them. And then when we explore the interaction among different agents, when different nodes are located in different spaces, so messages are transmitted over a significant range, we need to ensure reliable channels and keep the whole process secure. And also, if in the system there is an LLM or similar model, generative model, this becomes a very sophisticated tool. When you're ranging some answers, for example, the language model can behave differently when answering certain questions, when you have the ranking, not to mention a multi-agent system. These are the challenges that we will need to face, but there are certain ideas, so the industry is developing very rapidly. Thank you very much. This gives me a hint for another question for Mr. Wang. We are discussing not even the autonomous nature of agents, but their ability to learn from each other. When one system borrows a strategy from another system and then starts improving itself, and it's very hard for us to keep track. So the question is, how do you think we should manage this environment where agents have learned to communicate with each other, sometimes in languages that we do not understand, in an environment where models create their own rules?
I'm not working in the field. Probably Evgeny can answer this question.
Ну, хорошо, мнение же вы, можно ваше услышать?
Okay, maybe the manager can answer this. Regarding your question, I can say this. If processes in a multi-agent system are slow, a human being can, of course, control certain things, can get involved, but if the processes are very fast and the system is very complex, then the person can only do something outside of the cycle, and the only way about this is to combine different tools. Of course, you always need to test the system for vulnerabilities. Next, you need to have some sandboxes, barriers, where the process would stop altogether when you go beyond the barriers. And then the person needs to have access to the button that holds the whole system. And there should be gates in between the different systems that can be closed down, shut down if needed, to prohibit transmission of data. And also the two-key solution when you need to once again stop data from being transmitted. And this is what's being developed now. How can you regulate this? With which document, which framework? Europe is currently developing such regulatory framework, and we are following suit. We have different documents, different regulations for autonomous systems. We still have these standards for different machines, equipments. It's just that this is a new level for IT systems. Thank you, Professor Wang. For forecasting, we use deep models with a huge number of parameters. To which extent and which solutions do you think will be adaptable for actual industrial tasks?
That's a very good question. I think recently I got involved in 4 real-world industry projects. Okay, I think people are looking for some explainable model. Then the model should be knowledge informed rather than simply training from so-called deep learning algorithm. But people don't feel safety when they use the model for industry precise. Okay, then I think explainable is one issue. And also, I again address these the lightweights. So I think traditional learning algorithm has a big issue. Okay, so that's I think now somebody told me we had long distance from academia of China engineering. So he said, in the future, we should have pay more attention on these advanced machine learning algorithms, so that can produce a real optimal lightweight model. Okay, so this is for industry AI, rather than for generative large-scale model for entertainment or information processing. So this is my understanding. Next generation, I truly believe industry AI will play the key role in the world.
Thank you. Thank you very much for your forecast. Please take your seats in the audience, and I now invite the final pair for today, the head of Fusion Braille Laboratory of Sberbank, Andrey Kuznetsov, and AIRI, and Ivan Oseledets, also from AIRI.
Andrey Vladimirovich,
Mr. Kuznetsov, you are a renowned expert in Gen AI. You're co-founder of Kandinsky models. We congratulate you with your release. Thank you very much. How's it going, by the way? Is it gaining popularity? Well, yes, the research of the product team show that the results are great. Thank you. In May this year, you have had it joint lab of Gen AI that was created by AIRI and Innopolis. What are the outlooks for the Gen AI model as part of our foresight? Yes, it is true. The Gen AI models are going to the next level of multi-model architecture, where text is the basis. Around the text, a lot of types of data are being built with which the model learns how to work. This year, we went to the new era of reasoning and the possibility of self-editing and self-correction of the model. And as part of our efforts in Innopolis, we learn how to adapt these models for the industrial applications and for the using them for industrial data and engineering. This year, we showed some great solutions for reverse engineering in heavy machinery and construction. For example, our quadrille model is developing greatly and shows fantastic results. You can see that Gen AI overall starts to converge and is intersecting with the industrial applications, which is very important. Thank you very much. It is my great pleasure to give the floor to a Russian mathematician, CEO of AIRI, the professor of Russian Academy of Science, Ivan Oseledets. He's in the top 20 researchers in the world in terms of the number of citations. You are one of the visionaries of foresight, by the way, and you started working on it before it went global. And in your latest interview, you said that it is not possible to develop superintelligence and strong intelligence. Well, now you have to explain us why do you think that way. Could you tell us what is the stage of AGI development? Thank you very much. Well, it's good that I'm read, including the interview is read, but first of all, you have to create AGI. You said that it's a buzzword, but something that we're there, but we're not there, although the way the science is going and the industry is going is pretty understandable. We're talking about the scaling of transformers with a large number of GPUs, and something that happened in February this year with reasoning, and we're talking about DeepSeek. I'll try to switch that. Nope, that doesn't work. Some other agents are doing that anyway. I'm going to talk with that without the slides. Let them just slide away by themselves. Anyway, reasoning and DeepSeek, two major things. The models that reason for a long time with a large context. At the same time, the cost of inference went down because you have to work with large context, but at the same time, the cost of one token went down tenfold. So this is an innovative development. The quality of the model improves. All the benchmarks went through quickly. It's actually right there on the slide. Thank you very much. Yeah, that's true. Yeah, I remember. Yeah, that's written there. The other story that is related to the robot that we have showed, that's the embedded AI going to the physical world. This is vision language models, VLMs, that are at this emergent state. I mean, without that, true AI is not possible. Self-reflection, something that was already demonstrated, and the interaction with humans, I think is for sure what we have to do. We have to have a proper assessment system, not the statical benchmarks that people just make repetitive tasks and train the model on them, and then they report 90%, and at the same time complicated tasks like finding new medications or working in healthcare or resolving some construction issues. They don't do that. So to create a real strong intelligence AGI, we need to resolve at least one task that humanity cannot solve by itself. Thank you very much. And to conclude, I would like to end with a question. What is the leap forward that you expect? The creation of fundamental models for robotic systems, one of them, but for foresight, not only in your area. What is your forecast when we reconvene a year after this conference? What leap through are you going to discuss? I think for sure we can talk about moving closer to the better understanding of the physics of the world and the time and space connections, because a large number of content, it is not only text but video, and this sequences, the temporary sequences with various links, it's a major challenge because it opens up a new wave of the synthesis of data that is needed in robotics, in driverless cars and driverless vehicles, with out of distribution situations or deviations in the behavior, and understanding physics, understanding the laws of the environment is a very important task that we are going to go to. It's like building Zeppelins right now. People thought that you just need to build larger Zeppelins to transport more people, and then planes were invented. It's like here, maybe some new architectures will be discovered that work differently. Well, immortality is something that we were discussing for a long time. Well, you need to work out the mathematics first. Okay, so the immortality is not on the table as for now. Thank you very much. A round of applause. Now, in the end, please scan the QR code and select the best name of our platform, of our uniting platform. 52 ideas of the names. The table was given with the names was given to GigaChat. We uploaded the file together with the report on our foresight. RAG worked it out, and the prompt was the following: you are the expert in communications and in naming. From 1 to 10, rate the proposed names for the foresight research and about the future of the fundamental technologies. So I would ask you to give us the top 7 of the names, and we're going to see the best option in live mode. Right, so maybe I have influenced the audience, AI Horizons, or maybe it's just a very beautiful name. 9 out of 10, 51% of the votes. Brain OS, second option. For future site. Singularity. AI Optimi, and AI International Platform, and Global Sprint. Right, so I guess right Horizons, right? Yeah, okay. Everyone's voted for that. Thank you very much. The first name, AI Horizon, has won. Let's have a great flight together. We're moving to the next sections. Thank you very much to Sber for organizing the event, and see you next year. A round of applause for the participants of the plenary session. I would like to thank all the scientists, globally renowned scientists, as well as the experts in AI. And a huge thanks to Dmitry Chernyshenko for moderation and summarizing the one-year foresight on AIJ. And now let's have a small break and prepare for the AI journey. We are reconvening in 10 minutes.